Moving on from adding and subtracting fractions with like denominators, we have fractions with unlike denominators, which is a different sort of challenge and much harder for many students, even though we spent a lot of time on equivalent fractions earlier in the year. It can stand a bit of review. So for the warm-up, we have Amelia and Rory have candy bars that are the same size, but Amelia's candy bar is cut into 12 equal pieces and Rory's candy bar is cut into 16 equal pieces. So right away I know that Amelia has twelfths. Amelia has twelfths. And Rory has sixteenths, because that's how many pieces their candy bars are cut into. After eating, they combine their leftovers. Combine means addition, so this is an addition problem. Amelia contributes 3 pieces from her candy bar, 3 out of 12. And Rory contributes 5 pieces from his candy bar, that's 5 out of 12. What fraction of candy bar is this all together? And that just confirms that it's addition, which we already got from earlier in the problem. So we have 3 twelfths plus 5 sixteenths. But we can't actually add these because the pieces are different sizes. So if I drew this, I'd have to have candy bars that are the same size. So that's 1 candy bar. That's 2 candy bars that are the same size, but their pieces are a different size. Amelia has 12 pieces, so I'm just going to cut that into 3. Let's use a line for that. 3 pieces this way. Try to get that as even as possible. And then 4 pieces this way. I know I can't make the pieces exactly the same size, but we should get an idea. And then Rory's is 16 pieces, so I know I can do that by doing 4 by 4. So let's do 4 going this way. That's not even. And 4 going this way. Not even. There. It's as even as I could manage. So, Amelia has 3 pieces. 1, 2, 3. And Rory has 5 pieces. 1, 2, 3, 4, and 5. So I need to add them together, but they're different sizes. These are much thicker than these. These are skinnier. But what some kids might notice from the picture is that they're the same width going left to right. They're a different height, but they're the same width. So 1 entire column here is the same as 1 entire column here. So really this problem is very easy. It's just fill in a column. It's split up differently as 4 pieces instead of 3, but it's the same width because this is 4 wide and this is 4 wide. So it's the same. So my answer, when you look at it that way, is very easy. It's just, well, that's 5, 6, 7, 8, 9 sixteenths, because these pieces are sixteenths. But let's go ahead and show that with numbers and see how we can solve that. The first step, what we did when I said that these are split into 4 columns and the columns are the same width on both, was I simplified. I divided by the 3 pieces in this column, divide by 3. So basically I'm smushing those pieces together into one tall piece. Smushing those 3 together, smushing those 3 together, smushing those 3 together. That's when I divide by 3, that means I'm combining 3 pieces together. So 3 divided by 3 is 1, and 12 divided by 3 is 4. See, I can't get from 12 to 16 by multiplying by a whole number, but I can get from 1/4 from 4 to 16. That makes it much easier. 4 times 4 is 16, and since I have to do the same thing to the top as to the bottom, I get 1 times 4 is 4, and 4 times 4 is 16. 4/16 plus 5/16 is equal to 9/16. So basically what I did was I deleted these lines, and what I'm doing now is not going to change my fraction. It's still the same amount shaded in, even though I delete the lines. It's a different number of pieces because the pieces are bigger. So now I have one piece, but that one piece is the same size as the 3 pieces that I had before, so I didn't lose any candy, I just put it together. And then when I multiplied by 4, I was splitting each piece into 4 pieces, so I put in new lines to match these. I put in a line through the middle, like this, to split this into 16ths, to make it the same as this one over here. So first I simplified, and then I made sure that the denominator was the same. We're going to be doing the same thing today. Our objective is that we will add and subtract fractions with unlike denominators to get answers in simplest form. We're going to look at that with simple fractions and also with mixed numbers. So first, I forgot to change the title here. Unlike denominators, we have to fully simplify answers and convert improper fractions to mixed numbers in order to get full credit on any given answer. So first we have 2/5 and 3/10, and we can't add fifths and tenths because they're different sizes. But the good thing about this is that fifths are twice as big as tenths. For example, if I draw a picture with tenths in it, there's 10 squares in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are tenths. If I put 2 tenths together, it makes a fifth. So each piece is twice as big because it's got 2 of the old pieces in it. But it's fifths now. 1, 2, 3, 4, 5. So I have 2/5. 1, 2, and 3/10. Well, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need 3/10. So that's 1, 2, 3. If I divide it into tenths, which I can easily do just by adding this line going across. Now I have tenths. Okay, so 2/5 is the same as 4/10. Because remember the 2/5 were right here, and when I split that line between them, split them back into tenths, there are now 4 of them. So I get that by multiplying by 2, because I split each piece into 2 to make 4/10. So 4/10 plus 3/10 is equal to 7/10. 1, 2, 3, 4, 5, 6, 7. So my answer, I can't simplify that, is 7/10. You do not have to use a picture. The pictures are just there if they're helpful. You can just use numbers, and sometimes just using numbers is going to be easier. So, next we have 3/8 plus 7/16. A good first step is checking, can I simplify anything? Because sometimes if you simplify first, it makes getting to the answer easier. Now 3 and 8 have no factors in common, so that can't be simplified. Same with 7 and 16. So since these can't be simplified, I'm going to go ahead and try and find something that the denominators have in common, because 8ths and 16ths are not the same size. But 8ths would have to be twice as big as 16ths, because there would be twice as many pieces in a figure with 16 pieces as there would be in a figure with 8 pieces. So that means that if I do 3/8 times 2, then I get, well, that's 6/16. And then I can add 6/16 and 7/16 to get 13/16, which is as simplified as it gets. If I show that with a picture, let's look at some eighths. 1, 2, 3, 4. These are my eighths. Whoa, it's kind of ugly, but you get the idea. Okay, in order to make 16ths the same size, I need twice as many because I have 8 here. 8 times 2 is 16, so if I need 16 pieces, then I need to split each of these pieces in 2 in order for them to be the same size. So, and you can't really see that they're the same size because of my ugly drawing, but aside from that. So that one's split into 2 pieces, those are split into 2 pieces, those are split into 2 pieces, and those are split into 2 pieces. So now we have, it's the same shape, and so, as it was before, each piece is equal to all the other pieces. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pieces now. Okay, 3/10 and 9/15. First, can we simplify? 3 and 10 have no factors in common, so no. 9 and 15 do have a factor in common. They can both be divided by 3. If I count by 3s, I get 3, 6, 9, 12, 15. So divide by 3. And we get 9 divided by 3 is 3, 15 divided by 3 is 5. So 3/10 and 3/5, but that still won't work because fifths and tenths are different. But if I multiply the fifths by 2, then I get tenths. 3 times 2 is 6, and 5 times 2 is 10. We get 6/10. So we can add 3/10 and 6/10 to get 9/10. Now, if I had not simplified, I could still get to an answer, because 15 and 10 can both make 30. 15 times 2 is 30, and 10 times 3 is 30. So I would have, well, 10 times 3 is 30, and if I cut these into 3 pieces, I have to cut each of these into 3 pieces automatically. So 3 times 3 is 9. And if I split these pieces in 2 to make 30 pieces, then the same thing happened to these because they're a part of it. So I got 18. And then I do 9 plus 18 is 27 pieces. But 27 pieces can be simplified by dividing by 3. And 27 divided by 3 is 9, and 30 divided by 3 is 10. So I can get to the same answer without simplifying first, I just simplify it at the end. Alright, now we have 5/8 and 3/12. So can we simplify anything here? Well, 5 and 8 don't have any factors in common, so no, not that one. But 3 and 12 I can both get to by counting by 3s, so I'm going to divide by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. And now I still need to get to eighths. So if I split these in 2, then I'll have twice as many pieces, so 8. And this one will be split into 2 pieces. So then I have 5/8 plus 2/8 equals 7/8. And that's as simple as it gets. Now we're moving on to subtraction, which is the same idea. It's just that we're going to subtract it when we're finished instead of add. First, can we simplify? 19 and 25 have nothing in common, so no. But 2 and 10 are both even, and even numbers can be divided by 2. So if I put 2 pieces together, I get 1, and if I put 10 pieces, if I put the pairs together, I get 5 pairs. 2 divided by 2 is 1, 10 divided by 2 is 5. Now I still need 25ths. So 5 times 5 makes 25. And then 1 times 5 is 5, and 5 times 5 is 25, so I get 5 25ths. And 19 25ths minus 5 25ths is equal to 14 25ths. Again, I did not have to simplify first. I could have gone to 50, 25 times 2, 10 times 5. And I would have gotten, well, 19 times 2 is 38, minus 2 times 5 is 10, 38 minus 10 is 28, 28 over 50, both can be divided by 4, and by 2, and 28 divided by 2 is 14, 50 divided by 2 is 25, so you get the same thing. It's just that I didn't have to deal with 50ths when I did it this way. Okay, same idea. 20 21sts minus 3 sevenths. That's as simple as it gets, and 3 sevenths also as simple as it gets, but sevenths go easily into 21sts just by multiplying by 3, by splitting those pieces up into 3 pieces. So 3 times 3 is 9, and 7 times 3 is 21. So it's 20 21sts minus 9 21sts. So we get 20 minus 9 is 11. 11 21sts. 3 ninths minus 2 15ths. Can we simplify? 3 and 9 are both multiples of 3, so we can divide by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. 3 can get to 15 by multiplying by 5. Times 5 over 5. 1 times 5 is 5, and 3 times 5 is 15, minus 2 15ths equals 3 15ths. But now we have an answer that is not simplified, so I can't put it down here yet, because I can count by 3's to get to 15. So, to simplify, I need to go ahead and divide by 3. Something that happens with subtraction sometimes is even when you use fully simplified, the lowest common denominator. When you use the lowest common denominator, you can still get an answer that needs to be simplified. So, 3 divided by 3 is 1, and 15 divided by 3 is 5, so the answer is 1/5. Here we have 16 24ths minus 8 15ths. Can we simplify? Yes. 16 and 24 they're both even. I could divide by 2. They're both multiples of 4. I could divide by 4. They're also both multiples of 8. That's the biggest number I can divide by, so I'm going to go ahead and do that. Because if I count by 8s, I get 8, 16, 24. So that means it's 2 out of 3. 2 times 8 is 16, 3 times 8 is 24. And now I need 15ths so that I can subtract. So I'm going to go ahead and multiply by 5 so that I can get 15ths. 2 times 5 is 10. 3 times 5 is 15. 10 15ths minus 8 15ths is 2 15ths, and that's as simple as it gets, so I can put that as my answer. From here we move into using mixed numbers. So your answer will have a mixed number, or there'll be a mixed number in the problem, or both. So we have 9 tenths and 9 15ths. First, can we simplify? Well, if I count by 3's, I can get to 9 and 15. 9 divided by 3 is 3, and 15 divided by 3 is 5. So it's 3/5. I still need tenths in order to be able to add. I need my pieces to be the same size. So if I do this by 2, then I'll get tenths on the bottom and 6 pieces on top. So I have 9 tenths and 6 tenths. Well, if I have 9 pieces and 6 pieces together, that makes 15 pieces. But my answer has to be simplified, and it can't have any improper fractions. This is an improper fraction, and it's not simplified. So we could either simplify first or turn it into an improper fraction first. I'm going to go ahead and simplify first. I know that these are both multiples of 5 because they end in 5 or 0. So I'm going to go ahead and divide by 5. And 15 divided by 5 is 3. 10 divided by 5 is 2. Now it's still an improper fraction. 2 out of 2 pieces would be a whole. So I have 1 whole in there. And 3 minus the 2 pieces that made my whole is 1 piece left over, 1/2. 3 halves is the same as 1 and 1/2. Alright, so now we have 1 and 5/8 plus 2 and 3/12. Can we simplify? 5/8 is as simple as it gets, but 3/12 can be divided by 3. And we get 2 and 3 divided by 3 is 1, and 12 divided by 3 is 4. So you'll notice I did not divide the whole number, because 3 over 3 is just 1, 2, and 2 divided by 1 is still 2. And this is still 3/12, and it's 1/4. Those are the equivalent. So I'm not touching the whole number. The whole number stays the same. I'm just simplifying the fraction. Now I need to deal with eighths. So I'm going to go ahead and multiply by 2. So what I end up with is 1 and 5/8 plus 2 and 2 over 8. 4 times 2. So I'm going to add my fractions first. 5 and 2 makes 7. That's 7/8. 1 and 2 whole numbers makes 3 whole numbers. So my answer is 3 and 7/8 because I can't simplify. Next I have 1 and 19/25 plus 8/10. Can I simplify 19 and 25? No, but 8/10 can be divided by 2. They're both even. So that's going to be 4/5. And I need to work with 25ths, so I'm going to go ahead and multiply by 5. So what I get is here I have 1 and 19/25, and here I have 4 times 5 is 20, and 5 times 5 is 25. So I need my whole number. Let me keep that. I'm also going to add 19 and 20 makes 39. But I have more than a whole here, because 25/25 would make a whole. So what I'm going to do is I'm going to add the whole to the one that I already have. So if I have a whole already and I take a whole out of here, I get 2 wholes. And 25 pieces makes a whole, so if I take those 25 pieces away from the 39 that I had, I end up with 14 pieces. 14/25. So my answer is 2 and 14/25. Moving on to subtraction. Again, I need a common denominator. This is as simple as it gets, 13/21. 6/7 also as simple as it gets, but 7ths make 21st when you multiply by 3. So we get 6 times 3 is 18, and 7 times 3 is 21. So it's 1 and 13/21 minus 18/21. But the problem here is that I can't take 18 pieces away from 13 pieces, so I'm going to have to borrow. So when I borrow, I'm taking away the 1 to get, I'm turning the 1 into a fraction that I can add in. So 21/21. Okay, 21 out of 21 is a whole. So 21 pieces plus the 13 pieces that I already have makes 34 pieces. So instead of 13, now I have 34. So instead of 1 and 13 21st, I have 34 21st. Those are the same. 34 21st minus 18 21st. 34 minus 18 is going to be 16. So our answer is 16 21st. And that's as simple as it gets, because this can be divided by 4, this can be divided by 3 and 7, nothing in common. So we're going to get 16 21st. 2 more subtraction examples. 2 and 3/9 minus 11/15. 11/15, that's as simple as it gets. But 3/9, those are both multiples of 3, so I can divide by 3. And I get 2 and 1/3. But these are 15ths, so I need to make 15ths. I multiply by 5 to get 15ths. So what I end up with is 2 and 5/15 minus 11/15. So I can borrow, at this point it's just like the subtraction we did in last class. I can borrow, I can draw a picture, I can do whatever I need to do. I'm going to borrow because I can't take 11 away from 5, so I'm going to borrow a whole. So if I take a whole away, I have one whole left. A whole is 15 pieces, so 15 and 5 makes 20. So I have 1 and 20/15 minus 11/15. And 20 minus 11 is 9. So I have 9/15, and then I still have my 1. And I can simplify that. Those are both multiples of 3. So I get 1 and 3 over 5. 1 and 3/5. I could have done that with a picture if I wanted. It's 15ths. I had 2 wholes and 5/15. So if a whole is 15, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 2 wholes, 1, 2, and then 5/15. 1, 2, 3, 4, 5. I need to take away 11/15. So I need to take away 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what I end up with is 1 whole and 5, 6, 7, 8, 9/15, which is what we got here. Lastly, 5 and 8/24 minus 3 and 8/15. Can we simplify? 8 and 15 are as simple as they get, but 8/24 can be divided by 8. Or 4 or 2, but 8 is the fastest way. And I get 5 and 8 divided by 8 is 1. 24 divided by 8 is 3. 5 and 1/3 minus 3 and 8/15. Oh, we need 15ths. Let's go ahead and multiply by 5. So we end up with 5 and 5/15 minus 3 and 8/15. Now, I can't take 8 away from 5, so I'm going to need to borrow. If I borrow 1 from the 5, I have 4 left. 1 is 15 pieces. 15 and 5 makes 20. 20 pieces minus 8 pieces is 12 pieces. And then 4 minus 3 wholes is 1 whole. And of course I can simplify, divide by 3, and I get 1, and 12 divided by 3 is 4, 15 divided by 3 is 5. 1 and 4/5. And I can show that with pictures. So a whole is 15ths. We put them both as 15ths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's a whole. I have 5 wholes. 1, 2, 3, 4, 5. And I have 5 pieces. 1, 2, 3, 4, 5. Take away 8 pieces. 1, 2, 3, 4, 5. 6, 7, 8. And 3 holes. 1, 2, 3. I'm left with 1 hole. And 5, 10, 11, 12. 12 15ths.